Hello everybody, and welcome to exercise 7. And in this exercise we're going to be talking about distance, velocity, and acceleration in the context of an applied problem. This is going to be a nice opportunity to think about those three concepts again and to reflect how they're related to each other through rates of change. Okay, so let's read this question together. So a helicopter flies along a north-south straight line. Okay, throughout its flight, the velocity is recorded. Velocity to the north is positive and velocity to the south is negative. And then the graph that they're giving us to the right is a graph of velocity. That's going to be important in this problem. Okay, so you can kind of notice the units here. We've got velocity in feet per minute and time in minutes. And in this video, we're going to see if we can do parts A through D of this problem. Okay, so let's start with part A here. They ask us, does the helicopter reverse its direction during the recorded flight? Okay, well, let's take a look at the graph. Now, it's really tempting to think that we might get a change of direction at these 2 points, okay? Because after all, the graph turns around. But do those 2 points represent changes in direction? Remember that what we're looking at is the velocity graph, not the displacement graph. Okay, so this point, for example, just says that the velocity reaches a peak of 500 feet per minute and then we start to slow down again. That's not a change in direction, it's a change in velocity. Okay, so we actually don't get a change in direction at those 2 points. Okay, so what about the question then? Does the helicopter ever reverse its direction? Okay, well, look at the graph again and notice that the graph is always positive. It's always above the t-axis. What does that mean in terms of the direction of the helicopter? Well, if you look back at the statement of the problem, it means that the helicopter is always flying to the north, always. And if it's always flying to the north, there's never a change in direction. Okay, so thinking about it that way, we would have to answer part A, no. We might give a reason here. So since the graph of velocity is always positive, the helicopter is always flying to the north. Okay, and since it's never flying to the south, there can't be a change in direction. All right, so there's our answer to A. And B, similar question, but now they're asking us about velocity. So does the helicopter ever change its velocity during the recorded flight? Okay, well, remember again that the graph that we're given here is velocity. So it's like asking you, do the output values of this function change with time? And certainly they do. Okay, we start down here with a velocity of 0. We work our way up to a velocity of 500 feet per minute, and you can see that the velocity is constantly changing as our output values change. Okay, so here the answer is definitely yes. Okay, and they ask another question with this. Okay, if so, approximately when is it flying the slowest and when is it flying the fastest? Okay, how would we answer those questions? Okay, well, the slowest velocity is going to be the place where the velocity graph has its minimum output value, and that would be here where we're right on the t-axis. The velocity is going to be 0. Okay, so slowest velocity at t equals 0. And we might just mention how we've identified that point. Okay, that was the smallest output value of our function. That's what told us that we have our lowest velocity at that point. Okay, what about the fastest velocity? Okay, I might change the wording there. Let's be consistent with the wording of the problem. So Okay, so flying the slowest at. It doesn't really matter a whole lot, but I'm going to go ahead and change the wording there. Okay, where is it flying the fastest then? Okay, well there we're looking for the biggest output value of the function, and you can see that the biggest output value is up here where we reach 500 feet per minute. Okay, and what time value is that? Well, looking at our graph, it looks like that happens at about 20 minutes, so t equals 20. Okay, and again, that was the largest output value. That's how we found that point. Okay, so I think we've answered part B there. Okay, let's move on to part C then. All right, so this is interesting. Now they're asking us about the acceleration, okay, of the helicopter. Does it change its acceleration during the recorded flight? Okay, well here we have to think about the relationship between velocity and acceleration. Okay, and you might remember from earlier in the course, that relationship looked like this. The acceleration is the derivative, the rate of change of the velocity. Okay, so since we're given a graph of the velocity function, we have to think about what is the graphical interpretation of v prime of t? Well, it's just the slope of the tangent line. So C, the first part of this is like asking you, does the slope of the tangent line to the velocity graph change? Okay, let's look at the graph again. And you can see that from the velocity graph, the slope is constantly changing, which means that the acceleration is going to constantly change. So first part of the answer to that is definitely yes. Okay. And the second part of that question is, oh, whoops, I'm sorry, we're looking at C here, not D. And the second part of it is asking, when is it accelerating the most? Okay, well, that would be like asking you, where is the slope of the tangent line the most positive? Where do we get the steepest positive tangent line slope? Okay, let's scroll up and see if we can take a guess about that. Okay, you think about it a little bit, and it seems to me that the steepest positive slope is maybe about here. You draw in that tangent line, that's going to be the biggest positive slope. And what would you say the t value is there? Maybe about 10. Okay, so I think we've answered the question about where the helicopter is accelerating the most. Okay, and we'll just say a word about how we came up with that. That was where we had the steepest positive tangent line slope. Okay, and I think we have just answered part C, and so we will look at part D now. Does the helicopter ever decelerate, okay, during the recorded flight? Okay, what would decelerate mean? Well, that would mean that we've got a negative acceleration in this particular problem. And so are there places where the slope of the tangent line is negative? Okay, I think you'll agree that there are some places where the slope is negative, so the answer to that part of the question is yes. And then the second part of it is asking us, where is it decelerating the most? That's like asking you, where do we get the steepest negative slope for the tangent line? Okay, if you kind of go to the graph, you will hopefully agree that it looks like we get our steepest negative slope about here. Okay, that's t equals 30. All right, so we have enough information to answer D here. Okay, yes, and we are accelerating, or I'm sorry, decelerating the most. Okay, at around, what was that, t equals 30? Yeah. Where we get the steepest negative tangent line slope. Okay, and I think we've finished parts A through D, and we'll look at the last part in the next video.